Hello, it's Eric here, and so welcome back to my series of videos on the latest discoveries in data science. And so the last time I checked, we stopped at discovery number 5, computational algorithms, and we did part 1, yeah, and where we looked at the EM method, one of the earliest developments in computational algorithms in data science, yeah. And so today we're going to look at part 2, yeah, of computational algorithms. And by the way, the background music that you're hearing, actually it's not music, but is my bird singing. Yeah, my bird is singing his heart out, giving me moral support. Yeah, and the bird is called Huamei in Chinese, or you can call it the Orchid cow in Indonesian, or just simply silver eye in English. Yeah, and so one of those noisiest birds. Yeah, but if you want your home to be livened up, but then a silver eye is probably your best bet, And so without further ado, let's bring back the page on the computational algorithms, yeah. So that's discovery number 5. Okay, so last time in part 1 we looked at the EM approach, yeah. And so today we're going to look at the second approach, which is the ABC, approximate Bayesian computing method, and also method number 3, which is algorithmic inference, yeah, not AI, And so let's start with approximate Bayesian computing, yeah. So let me take a deep breath and I'll explain it to you in very simple English, yeah. So as the name suggests, approximate Bayesian computing is based on the concept of Bayesian analysis, yeah. So Bayesian basically is a method in statistics where you have a prior belief about some distribution, yeah. Like for example, here I'm interested in the distribution of the age of the people in the U.S. population, yeah. So let's say I have a prior belief about the the distribution of the ages of the people in the U.S., yeah. And the goal of Bayesian analysis is to update my prior belief about the age distribution into a posterior belief about the age distribution, by looking at some of the collected data, And so first of all, let's say I have a prior belief about the age population of the U.S. population. That means the age distribution, yeah, distribution of the ages of the people in the U.S., yeah. So let's say, for example, my prior belief is like a uniform distribution, yeah. So uniform distribution basically means that everybody has the same chance of appearing in the age distribution, yeah. That means you have the same chance of being a 5-year-old as being a 50-year-old, yeah. That's the meaning of a uniform distribution, yeah. And but of course that's not true, The U.S. population has a age distribution that is very different from the uniform distribution, And so therefore, how different? Well, so therefore you go and collect a sample of data, about the ages of, let's say for example 100 people, yeah, randomly selected 100 people in the U.S. Population, yeah, in different districts, And then so then the next step in ABC is to calculate the chance, the chance of observing all these data points in your sample, And so what you do is, sometimes it's very difficult to compute the chance of observing the data points in your sample, And so what you do is, you're based on some kind of underlying probability distributions. Yeah, you come up with different probability distributions of observing your data points. Yeah, and then you do a simulation on each of those underlying probability distributions. Like for example, I can use simulation method 1 based on distribution probability distribution number 1 to simulate the chance of observing my data point. And then I do a second simulation, and then do a third simulation, and then do a fourth simulation. Let's say, for example, I simulate the chance of observing my data points 10 times, yeah? And out of those 10 simulations, I find out that, let's say, for example, simulation number 7 gives me the highest chance, of observing the data points in my sample, And so therefore, I can use the underlying probability distribution for simulation number 7 to update my prior belief about the age population into a posterior belief about the age population, So basically, it's it's like a 3-step procedure, yeah. ABC computing basically is a 3-step procedure. First of all, you have a prior belief about the age distribution of the U.S. population, and then you do a lot of simulations and to see which simulation method can give you the highest chance of observing the data points in your sample, And then based on this simulation method that can give you the highest chance of matching the data points in your sample, then you use this simulation method to update your prior belief. into a posterior belief about the age distribution of the U.S. population. Yeah. So it involves a lot of simulations, and so therefore they call it approximate Bayesian computing. And so that's the second method. Let me take a deep breath and we'll go to the third method. Yeah. Okay, I've taken a deep breath, and so let's look at generic computational algorithm number 3. This is probably the most advanced form of the generic algos. Yeah. And so, by the way, let me remind you that all these computational algorithms. The purpose of all these computational algorithms is to devise some kind of general computing method that can be applicable in different circumstances. You can do it in engineering, you can do it in medicine, and you can also do it in statistical science. Yeah, then it's a data science. Yeah, and so the last one, the algo inference technique, the computational algorithms based on algorithmic inference is basically making very heavy use of machine learning. Yeah. And so first of all, machine learning, as you may or may not know, machine learning, the purpose of machine learning is to make an accurate prediction, And so let's say, for example, here, let's say, for example, I want to predict the average age of the population in the U.S. Yeah. And so based on lots of collected data, like for example, I can know where the people live and what kind of eating habits they have, or what kind of exercise habits they have, but I don't know their age, and so therefore I use all these auxiliary information to help me to predict the the average age of the people in the U.S. population. Yeah, and so the main goal of machine learning is basically just to make prediction, to make accurate prediction, And but nowadays, in statistics or data science, people are using machine learning algorithms not just to do to make accurate prediction, but also to do statistical inference. And as you know, from your very basic elementary statistical training, you know that statistical inference basically has two kinds of reincarnations. Yeah, that means two ways to do statistical inference. The first one is confidence interval. Yeah, that means you can based on some sample data, I can calculate the confidence interval of the average age of the U.S. population. So you can say, well, after some computations, I can say I'm 95% confident that the average age of the U.S. population is between 40 and 50 years old. Yeah, and I'm 95% confident of that. And so that's the first methods in statistical inference, confidence interval estimation. And the second method is, of course, hypothesis testing, which we're not going to cover, But I just want to bring your attention to the fact that, they can actually use the machine learning algorithms to do statistical inference. That means they can use machine learning algorithms to calculate the, for example, the 95% confidence interval of the average age of the U.S. population, And so I'm not going to go into the details, Like there are so many very well-known, very famous machine learning algorithms like decision tree and support vector machine and things like that, And so if you're interested, you can look up all those. But my point here is that all those machine learning algorithms, traditionally those machine learning algorithms are used for accurate prediction. But nowadays, scientists are trying to use these the same machine learning algorithms, like for example decision tree, support vector machine, to help them to do statistical inference. Like for example, calculate the confidence interval of the average age of the U.S. population. Yeah. So instead of using traditional statistical method to calculate, say for example, I'm 95% confident that the average age of the U.S. population is between 40 and 50 years old. Yeah. Instead of using traditional, statistical methods, like for example, calculating the sample mean, calculating the sample standard deviation, I don't want to use those methods. I want to use the new methods based on machine learning algorithms, so that I can arrive at the same kind of, probabilistic statement. Like for example, I'm 95% confident that the average age of the U.S. population is between 40 and 50 years old. Yeah. So that is probably the latest cutting edge in the development of computational generic algorithms, in terms of data science. Yeah, is to use all those traditional, very famous machine learning algorithms to help you to do statistical inference. Like for example, calculating a probabilistic confidence interval. Like for example, for the average age of the U.S. population. Yeah. And so that's it. I think I have I hope I have done a good job in explaining these typical concepts to you. Yeah. And I promise that the next few discoveries are not that technical. Yeah. And so I'll see you in the next video. All right. See you. Bye.